It doesn't look like a typical comet where you see a beautiful tail of dust stretching away from the direction of the sun. So it looks still quite anomalous. It's similar to the image we obtained from the Hubble Space Telescope on July 21st, which was enigmatic because there was an extension of the image in the direction of the sun as if there is a jet that is luminous in the direction leading to the sun rather than away from the sun the way we see for comets. So we see now that it passed near Mars, and there will be much better data. The best is yet to come from the high-rise camera on board NASA's Mars Reconnaissance Orbiter. The data was taken, but because of the government shutdown, we haven't seen it.
On October 29th, 3I Atlas will vanish behind the sun. Just as Avi Loeb warns, it may attempt a maneuver to stay in our solar system forever. Officially, it's just a comet. Yet the numbers don't add up. A 20-kilometer nucleus, 33 billion tons of mass, and almost no acceleration. If Loeb is right, everything changes. When astronomers first ran the numbers on 3I Atlas, they weren't prepared for what they found. At first glance, it looked like another comet, a bright visitor with a glowing coma, venting gas as it closed in on the sun. But within days, cracks began to appear in that story. The data wasn't just unusual, it was alarming. The initial size estimate landed like a thunderclap, nearly 20 kilometers across. To put that into perspective, the first interstellar visitor, Oumuamua, was less than 250 meters wide. The second Borisov stretched about a kilometer. But Atlas, at least 20 times larger than Borisov and hundreds of times more massive. Early brightness models and reflectivity calculations pointed to a nucleus weighing more than 33 billion tons. That figure alone broke expectations. Here's why. In survey science, big objects are supposed to be rare. Smaller interstellar wanderers should outnumber giants by thousands to one. That's what every population model predicts. And yet, in the space of just a few years, humanity's first 3 interstellar detections span from the tiny and faint to the statistically impossible. It's as if the universe skipped straight to a heavyweight contender. But the real paradox wasn't its size. It was its behavior. Despite vigorous outgassing between 100 and 150 kilograms per second dominated by carbon dioxide, the comet showed almost zero non-gravitational acceleration. In comet science, this is the rocket effect. As jets of gas vent into space, they act like thrusters, nudging the object off course. Every known comet does it, sometimes enough to complicate orbital predictions. But Atlas, nothing. Its motion was almost too perfect, hugging the trajectory set by gravity alone. The Minor Planet Center's database logged thousands of positional measurements. Each confirmed the same thing. The expected acceleration wasn't there. For any ordinary comet, outgassing at that rate would leave fingerprints in the astrometric record. A slow drift, a subtle curve. But the upper limit for Atlas was so low that only a massive, incredibly dense object could explain the silence. And that silence is what caught Avi Loeb's attention. Monte Carlo simulations ran through every possibility. What if the nucleus was smaller? What if its density was lower? Every run broke down. Outgassing should have shoved Atlas off course unless it was either unnaturally massive or its jets were somehow firing in perfectly balanced opposition, canceling each other out with precision. The odds of such symmetry occurring by chance are vanishingly small. That's why skeptics began whispering, could Atlas be more than just ice and dust? Spectroscopy only deepened the riddle. Instead of water vapor, the dominant driver in nearly all known comets, Atlas was spewing carbon dioxide in overwhelming amounts, almost an 8-to-1 ratio compared to water. For our solar system, that's alien chemistry. To accumulate so much CO2, Atlas must have formed in conditions bitterly cold, perhaps circling a distant star in perpetual freeze. But even that explanation raised another question. How did such a body find its way here now on such a fine-tuned path through the solar system's ecliptic plane? Taken together, the anomalies stacked up. Size far too large for early detections, massive outgassing without acceleration, an orbit hugging the planetary plane instead of slicing through at random, chemistry unlike anything local comets display. Individually, each quirk might be dismissed, but as Loeb argues, when enough anomalies cluster together, the case for just a comet grows weaker, and that's the chilling possibility. 3I Atlas might not just be another interstellar wanderer, it might be the first one that refuses to play by any natural rules. If the size and chemistry of 3I Atlas already raised eyebrows, its trajectory turned them into alarm bells, because under the laws of orbital mechanics, this object shouldn't look the way it does. For most interstellar visitors, the story is simple. They arrive on steep hyperbolic paths, slicing through the solar system at odd angles, and then they vanish forever. That was the case for Oumuamua in 2017, an elongated enigma accelerating slightly before vanishing into the void. It was true again for Borisov in 2019, a more traditional comet, but still clearly on a one-way ticket through our neighborhood. But Atlas is different. Trajectory maps reveal a path that hugs the ecliptic plane, the thin disk where Earth, Mars, Venus, and the other planets orbit. Its inclination is only about 5 degrees. That's shockingly low for a random interstellar arrival. Statistically, most outsiders should cut across at angles of 30, 60, or even 90 degrees. Instead, Atlas glides almost perfectly along the same plane that our solar system has followed for billions of years. To planetary dynamicists, that alignment is a statistical anomaly. To Avi Loeb, it looks uncomfortably precise. And then there are the planetary flybys. On October 3rd, Atlas sweeps within 29 million kilometers of Mars, a distance that counts as a close shave on interplanetary scales. Just weeks later, its course carries it within striking distance of both Venus and Jupiter, stacking up a sequence of encounters that seem less like chance and more like choreography. The compounded odds of a 20-kilometer interstellar object threading this exact corridor and doing so at such speed are vanishingly small. For each planet, the odds of a close pass are low. For 3 in a row, the probability drops below 1 in 1,000. And yet, here we are, watching an outsider drift through our system as though it had a flight plan. Why does that matter? Because each planetary flyby offers an opportunity for gravitational assists, tiny nudges that can alter speed and direction. Space agencies use them all the time when slingshotting spacecraft across the solar system. But when a natural body like Atlas executes the same moves, the question becomes unavoidable. Is this coincidence, or is something more deliberate at work? The paradox deepens as we approach perihelion, October 29th, when Atlas dives behind the Sun. At that moment, its velocity will peak at nearly 44 kilometers per second, an interstellar bullet arcing just 1.36 astronomical units from the solar furnace. This is the point of no return. If Atlas is truly a comet, it will whip around the Sun and continue on its outbound hyperbolic path. But if it performs even a modest maneuver, a delta V of about 8 kilometers per second, its trajectory could shift from escape to capture, trapping it in our solar system forever. And here's the cruel twist. We won't see it happen. At conjunction, the geometry locks Earth, Sun, and comet in a straight line. The Sun's glare overwhelms every Earth-based telescope, Even space observatories like Hubble and JWST are forced into safe mode, unable to risk pointing near the solar furnace. For nearly 6 weeks, from late October through early December, Atlas will be invisible. The very moment when the decisive maneuver, natural or otherwise, could occur is the one moment when we can't watch. That blackout leaves astronomers in agony. Will Atlas behave like every other comet, venting and blazing before vanishing back into interstellar space? Or will it emerge on the other side with a new orbit, one that keeps it bound to the sun, circling like a captured satellite of the solar system itself? The scientific establishment leans toward caution. NASA's official line is that comets are unpredictable and that Atlas, though unusual, still fits within the messy variety nature produces. Outgassing can vary wildly, chemistry can surprise, orbits can align by chance. For many astronomers, that explanation is enough. But Avi Loeb isn't convinced. For him, the anomalies are too many and too precise. A nucleus too massive, a trajectory too aligned, flybys too perfectly arranged, outgassing without thrust. Each one on its own might be rare. Together, they form a pattern that demands attention. As Atlas disappears into the solar glare, the debate hangs unresolved. Are we about to witness the first interstellar body ever captured by the sun? Or are we letting imagination run wild on the back of improbable numbers? The answer will only arrive in December, when Atlas re-emerges from behind the sun, and by then, it may already be too late to change the story. If 3I Atlas's orbit raised suspicions, its chemistry pushed the debate into uncharted territory. Spectroscopic data from early September gave astronomers a shock. Instead of water vapor, the dominant volatile in nearly every comet we know, Atlas was spewing carbon dioxide at nearly 8 times the rate of water. For solar system comets, water is the main fuel. Carbon dioxide is usually secondary, appearing in smaller fractions. But Atlas flipped that balance upside down. The ratio hinted at an origin in conditions so cold that even water stayed frozen solid, while CO2 dominated the crust. Perhaps it formed in a distant star system, orbiting far beyond its parent star, where temperatures plunged hundreds of degrees below freezing. If true, Atlas could be carrying the chemical fingerprints of alien worlds, icy planets broken apart and scattered into interstellar space. But the strangeness didn't end there. In late September, telescopes recorded a sudden green glow spreading through the coma. Amateur and professional astronomers alike reported the surge, tracing it to molecules like C2 and CN fluorescing under solar ultraviolet radiation. Normally, this emerald hue peaks close to perihelion when sunlight is strongest. But for Atlas, it arrived early, brighter and faster than models predicted. The timing puzzled scientists. Why would a comet erupt with spectral signatures weeks ahead of schedule? Some argued it was a crust breaking open, exposing fresh ices beneath. Others suggested layered chemistry, volatile gases stacked like geological strata, released in bursts. But to skeptics like Avi Loeb, the timing raised another possibility, that what we were seeing wasn't random venting, but a controlled sequence of events. Add to this the optical asymmetry. Early imaging from Gemini South and the Very Large Telescope showed a concentrated glow on the sunward side, too sharp, too bright, before an ordinary tail formed. Analysts ran corrections for smear, geometry, and instrument error. The anomaly held. Something about Atlas's emissions didn't fit the template of natural comets. Each piece of evidence stacked atop the last. A nucleus too large, outgassing without acceleration, an orbit aligned too closely to the planetary plane. chemistry that looked engineered rather than accidental. For mainstream astronomy, the explanation is still conservative. Comets are messy, unpredictable, and full of surprises. But for Loeb, the clustering of anomalies paints a different picture. Atlas doesn't just defy expectations, it systematically refuses to behave like a natural body. And that leaves the most unsettling question hanging. If this isn't coincidence, what exactly is hiding inside that crimson veil? For most astronomers, 3I Atlas isn't just a curiosity, it's a statistical nightmare. Every model, every survey expectation, every population study has been thrown into doubt by this single object. Let's start with the basics. Population science says that in any asteroid or comet belt, small bodies vastly outnumber giants. For every massive 20-kilometer wanderer, there should be thousands, maybe millions of tiny fragments, only a few hundred meters wide. If our surveys are working, those should be the first things we detect. Faint, fast-moving rocks barely large enough to leave a trace. That's exactly what happened with the first two interstellar discoveries. Oumuamua was tiny, less than a quarter of a kilometer long. Borisov stretched about a kilometer, faint but textbook in its behavior. Both fit expectations. Early interstellar detections should hover at the threshold of visibility. And then came Atlas. At nearly 20 kilometers wide and weighing more than 33 billion tons, it leapt straight to the top of the charts. No gradual progression, no swarm of smaller cousins discovered first, just a giant, blinding anomaly. Statistically, the odds of finding such a body before its smaller relatives are less than 1 in 10,000. The Pan-STARRS survey, the Atlas Network, and the Vera Rubin Observatory have spent years sweeping the skies, logging millions of detections. Their sensitivity is now so sharp, they can spot objects just a few dozen meters across. By all rights, we should have cataloged hundreds of interstellar minnows by now. But instead, the first heavyweight appeared before the population it was supposed to belong to. That's why analysts flagged Atlas immediately. In private memos and internal reports, survey scientists warned that the power law, the backbone of size distribution, appears broken. The discovery pipeline didn't behave the way the math says it should. Either the universe is hiding a vast, unseen population of faint interstellar bodies, or Atlas is an outlier that defies everything we thought we knew. For Avi Loeb, that distinction is critical. If Atlas is truly natural, then survey science has a gaping blind spot, and that in itself is alarming. But if it isn't natural, if its sheer size and perfect timing are part of a pattern, then the implications are even more unsettling. The trajectory compounds the mystery. Instead of slicing through the solar system at a random angle, Atlas drifts almost perfectly along the ecliptic plane, the thin disk where Earth, Mars, and the rest of the planets orbit. Its inclination is just 5 degrees. For an interstellar arrival, that's extraordinarily rare. And then there are the planetary encounters. October 3rd, a flyby of Mars at just 29 million kilometers. Weeks later, a pass near Venus. Later still, an approach within gravitational reach of Jupiter. Dynamicists calculated the compounded odds of such a sequence and found them vanishingly small. For each planet, the chance of a near miss is already low. For 3 in succession, the probability falls below 1 in 1,000. To mission planners, that pattern looked less like coincidence and more like design. After all, spacecraft regularly use gravity assists, slingshot maneuvers that let them change speed and direction without using fuel. When an interstellar body executes a similar run of encounters, the possibility of deliberate choreography becomes harder to dismiss. And the final act comes at perihelion, October 29th, when Atlas swings behind the Sun. At that moment, moving at nearly 44 kilometers per second, a single push, a delta V of about 8 kilometers per second would be enough to capture it. Instead of racing back into interstellar space, it could remain bound to the sun, circling forever. But here's the cruel irony. That moment will be hidden. The solar glare blinds every telescope on Earth. Hubble and JWST go dark under safety protocols. Even coronagraphs will struggle to detect anything fainter than magnitude 8. If Atlas performs a maneuver, natural or engineered, it will happen where no one can see. For mainstream astronomy, the answer is simple. Atlas is just another messy comet, a statistical fluke that looks strange only because interstellar science is still so young. But for Avi Loeb, the clustering of anomalies, size, chemistry, trajectory, and timing is too deliberate to ignore. And as the comet vanishes into the solar glare, the clock begins to tick. When it reemerges in December, astronomers will have just one question. Did it stay on its hyperbolic path, or did something extraordinary happen behind the veil of the sun? Because if Atlas has truly shifted into a bound orbit, then the bombshell is real. Our solar system may have just gained its first permanent interstellar resident. By now, the official narrative about 3I Atlas tries to keep things simple. It's labeled a comet, an interstellar visitor forged in some frozen wasteland around another star, venting carbon dioxide instead of water, cloaked in a haze of alien chemistry. That's the comfortable story. Clean, logical, natural, but the numbers refuse to cooperate. A nucleus nearly 20 kilometers wide, weighing more than 33 billion tons. Outgassing rates between 100 and 150 kilograms per second. And yet, virtually zero non-gravitational acceleration, the subtle nudges every comet should show when its vents push against the void. For Atlas, the rocket effect is absent. The math only works if it's unbelievably massive, unnaturally dense, or somehow venting in ways so balanced they cancel perfectly. That's why Avi Loeb and others argue the mainstream explanation feels like a patch, not an answer. Atlas doesn't behave like a comet. It behaves like something else. And then comes the timing. On October 29th, 2025, Atlas dives behind the sun. Perihelion, the defining moment of its journey. For nearly 6 weeks, from late October through early December, every Earth-based telescope will be blinded. Even Hubble and JWST will be forced into silence, unable to risk their optics against the solar glare. The exact window when any maneuver could occur, the one chance to tip Atlas from a fleeting visitor into a permanent resident, will unfold unseen. That enforced blackout haunts astronomers. If Atlas is natural, the data gap is frustrating but harmless. We'll pick up its trail again in December, confirm its orbit, and move on. But if it's not natural, if it performs even the smallest maneuver, just 8 kilometers per second of delta V, then we may have witnessed history's first interstellar capture. And we'll have missed it. This is the paradox at the heart of the debate. On one side, NASA and the broader community argue comets are messy, unpredictable, and prone to surprises. Odd chemistry, strange trajectories, unexpected alignments. It all fits, if awkwardly, within the chaotic rules of nature. For them, Atlas is extraordinary but not impossible. On the other side, Loeb stacks the anomalies. Size, mass, chemistry, lack of thrust, orbital alignment, planetary flybys arranged like stepping stones. Individually, each quirk might be rare. Together, they form a pattern that feels deliberate. And when enough anomalies cluster, the responsible move is to take the possibility seriously. That's what makes this moment so unsettling, because whether Atlas is a comet, a relic, or something engineered, it is forcing us to confront questions bigger than astronomy. Are we really seeing chance at work or design? Is this just another icy rock from the stars, or the husk of something older, technological, cloaked in the disguise of a comet's veil? And maybe the scariest part isn't what it is, but what it represents. For centuries, humanity never confirmed a single interstellar visitor. Then, within less than a decade, 3 arrived: Oumuamua, Borisov, and now Atlas. Each one stranger than the last. A sliver accelerating without thrust. A textbook comet, reassuring but fleeting. And now a colossal body that bends every rule at once. Coincidence or a sequence? If Loeb is right, we may not just be studying a comet. We may be witnessing the first interstellar object to remain with us, anchored to the sun, circling forever, a permanent reminder that the universe beyond is not empty, but restless. By early December, the story will continue. Atlas will re-emerge from behind the sun. Every observatory will be watching, from ground-based telescopes to orbiting instruments. Its orbit, rotation, and chemistry will be measured with obsessive precision. If it stays hyperbolic, the natural explanation holds. If not, if its path has shifted even slightly, the debate enters a new phase, one that science can't easily dismiss. And so the clock ticks. On October 29th, Atlas disappears into the sun's blinding shadow. What happens there could decide whether this story remains an astronomical anomaly or becomes the biggest discovery in human history. Because if Avi Loeb is right, the bombshell isn't just that Atlas is unusual, it's that it may already be part of us, stuck in our solar system forever. So here's the question I'll leave you with. When Atlas reappears in December, what will we find? A comet obeying physics? Or a visitor rewriting the rules of the universe? If you want to be here when the answers arrive, make sure you subscribe, hit the bell, and join us, because what happens next will shape the way we see the cosmos, and maybe ourselves.